Welcome back to Bargaining and War. This lecture is continuing our exploration on preventive war, so let's get right to it. Last time, we found out what happens in the post-shift world. After A has become relatively weaker and B has become relatively stronger, we see that peace will prevail. In particular, A will make a demand x2 equal to P plus CB, and B will accept. Again, we get peace. What we need to do in this lecture is use that information to structure the payoffs for what's going to happen in the first stage and solve for the equilibrium actions in that first stage. This has a bunch of different components. First, we need to figure out whether A is going to fight a preventive war. The answer is no. We need to figure out what A is going to make as its demand x1, which is some quantity between 0 and 1. And once A has made that demand, we need to figure out whether B will accept or reject. So as always, we're going to apply backward induction here, which means the next thing we need to figure out is whether B is going to accept or reject. Now, fortunately, the work that we did in the previous lecture is going to simplify this question a great deal. Take a look at the payoffs that I've written in the bottom half, and specifically look at that bottom row, the pre-shift acceptance payoff. This is the utility that B would get if it accepts a demand. So let's look at the bottom right and figure out what is happening there. B is getting 1 minus x1 to reflect its payoff for accepting in the first stage. This is how much utility it will accrue in that pre-shift world. What's new here is what's happening in the second part of the game. Before, we had written this as delta times 1 minus x2 divided by 1 minus delta. The reason that we had x2 there is because we didn't actually know, necessarily, what B's payoff was going to be for the second stage. But now we know what that's going to be. We have solved for the equilibrium of the post-shift world, and we know that B is going to get the remainder of the deal being x2 equal to P plus CB. So the remainder of that, of course, is 1 minus P minus CB. So that's why we have B's payoff fully filled in for the second stage. And similarly, if we look right here, we've also put in that demand quantity, the equilibrium demand quantity of P plus CB into that part of A's utility. Okay, with that description out of the way, we can answer what's happening here between B's accept and reject decision. That accumulates to just looking at this versus this. We have B's payoff for a pre-shift war of 1 minus P prime minus CB divided by 1 minus delta. And we have its pre-shift acceptance payoff of 1 minus x1 plus delta times 1 minus P minus CB divided by 1 minus delta. So B is going to accept a demand as long as this quantity here is better than this quantity here. Let's go ahead and write out that inequality. So B will accept if 1 minus x1 plus delta times 1 minus P minus CB over 1 minus delta is at least as large as 1 minus P prime minus CB over 1 minus delta. Well, we're thinking about this as B accepting or rejecting a demand of x1, so we should put this in terms of x1. So let's go ahead and move x1 over to here and move that fraction to the other side as well. If we do that, well, let's see, we got x1 less than or equal to 1 plus delta 1 minus P minus CB divided by 1 minus delta minus 1 minus P prime minus CB over 1 minus delta. The right-hand side of the inequality is a little complicated, and in fact, we can simplify this to some degree. Let's go ahead and put everything into the same fraction. We still have x1 on the left-hand side. We're going to multiply 1 by 1 minus delta and then divide it by 1 minus delta to get an equivalent value. And if we do that, then we have 1 minus delta. I'm going to go ahead and distribute this delta all the way through, plus delta minus delta P minus delta CB. And then I'm going to distribute this negative all the way through, minus 1 plus P prime plus CB. If I did that right, we just divide everything by 1 minus delta, and we have a single fraction. And by doing that, we can see how this is simplifying. We have a 1 here and a 1 here, or a negative 1 there. And so those two things get deleted. We also have a negative delta and a positive delta, so those two things get deleted as well. We can do a little bit more simplifying as well by noting that we have a CB and a negative delta CB right there and right there. So we could write that as CB 1 minus delta, which would cancel out with the denominator. So if we fully simplify this, we get x1 less than or equal to p prime minus delta p divided by 1 minus delta plus cb. So to interpret what's going on there, remember that x1 is A's share of the good, and so if A is getting a sufficiently small amount, then B is happy to accept A's demand because that's leaving a lot left over for B. And what is defining a sufficiently small amount is p prime minus delta p divided by 1 minus delta plus cb. Now, usually when we're looking at these one-shot games, this is not a one-shot game, of course, this is multiple periods of bargaining. But in those one-shot games, we assume that B has a positive war payoff. And we're still assuming that B has a positive war payoff here. But there's a slight complication with what's happening with this value overall on the right-hand side. Usually, we have to have A make some sort of concession to B to get B to accept a deal because B has a positive value for war. Here, however, it is possible that P prime minus delta P divided by 1 minus delta plus CV is greater than 1. And if that is the case, then B will accept any demand whatsoever because X is a value that's between 0 and 1. So anything that A would choose between 0 and 1 would definitely be less than this value here if that value is larger than 1. Substantively, what's going on there? Well, think about what is happening with B's dilemma. If B fights a war in the first stage, it's doing so under disadvantageous circumstances. It would rather fight a war, all else equal, after power has shifted because it's going to be stronger at that point. Now, obviously, once power has shifted, it's not going to fight a war. In fact, it's going to be bought off. But A is going to be buying off B at a rate commensurate with B's newfound power. And so if B is looking into the future and seeing that, yes, I'm going to be getting a lot of stuff in the future, then it is worth not bothering to fight a war today despite not getting any sort of settlement today, just so that B can secure all of that great stuff later on. To do a little bit of better bookkeeping on this, let's put this in terms of delta. So to put this in terms of delta, we need to multiply both sides by 1 minus delta to get rid of the fraction. 1 minus delta. Let's put delta on the left-hand side and every other term without delta on the right-hand side. Just got to be careful with the negatives. Make sure everything is consistent. Okay, now that we've done that, we just pull out the deltas. 1 minus P minus CB greater than 1 minus P prime minus CB. And then we can divide off what we have there to get a final statement. 1 minus P minus CB. So you'll notice that we don't have to worry about flipping the inequality because 1 minus P minus CB is B's war payoff for the second stage, and we're assuming that that's a positive value, that B is getting some sort of positive quantity by fighting a war at that stage, so we don't have to worry about a negative value and then flipping the inequality. Okay, so this is giving us a couple of different parameter spaces. This is saying, we just draw this out here on a number line, this is delta. We have 1 minus P prime minus CB over 1 minus P minus CB. If we are in a value to the right of that, then we have B accepting all X1 demands. And to the left, we have B rejecting some X1 demands. So why is it that B is accepting all demands when delta is sufficiently large? Well, think about it this way. If delta is large, then B places a lot of value on the future. And so fighting a war under disadvantageous circumstances today, just to get some benefit today, is not worth it if B cares a lot about the future. Okay, from here, we need to solve this in two different cases. One where we have delta larger than that cut point, and one where we have delta smaller than that cut point. We have again solved for B's decision, so now all we need to do is figure out whether A is going to make a demand, if so, what demand is it going to make, or whether it's going to fight a war. Let's first cover what happens when delta is large, when delta is larger than that cut point. So B is accepting all x1 demands. Let's scroll up and look at this game. So this is the thing that we need to solve for now, whether A is going to make a demand or prevent. So this is a two-part decision for A. The first thing that A needs to work out is what is its optimal demand, and then it can compare that optimal demand to what it would get by preventing. Let's first figure out what the optimal demand is. Well, we have A's payoff for acceptance right there, x1 plus delta times P plus CB divided by 1 minus delta. And very clearly, A's payoff strictly increases in x1. So if A wants to make an acceptable demand, it needs to make x1 as large as possible without having B reject. But as we've seen, if delta is large, then B accepts all demands. And so, in fact, A can make x1 equal to 1 and get away with it. That doesn't necessarily mean, however, that A is actually going to prefer that. A still has to compare its payoff for substituting x1 equal to 1 compared to this quantity here, what it gets from a pre-shift war, if it prevents. So let's figure out whether A is going to prefer to make that demand of x equal to 1 or prevent instead. So A is going to choose to prevent if P prime minus CA over 1 minus delta is larger than 1, that's how much it's getting for demanding everything in this first stage, plus delta times P plus CB over 1 minus delta. Well, we've put the previous decision in terms of delta, so to see if we can get some mutually coexisting parameter spaces here, we should put this term as well in terms of delta. So let's do that by multiplying everything by 1 minus delta to get rid of those fractions. If we do that, we have P prime minus CA greater than 1 minus delta plus, and I'll go ahead and multiply out the delta. Let's see, let's put all of the delta terms on the left-hand side. I know that might seem a little bit strange because we already have 3 terms of delta all on the right, but in fact, this is going to be a negative value, and so to avoid having to worry about flipping inequalities later, let's just go ahead and move them over. So 1 minus, or rather delta minus delta P minus delta CB greater than 1 minus P prime plus CA. Then we undistribute the delta, 1 minus P minus CB greater than 1 minus P prime plus CA. Don't have to worry about flipping the inequality because this is, again, B's war payoff, so that is a positive quantity. And we get 1 minus P prime plus CA over 1 minus P minus CB. Okay, so if we have delta being sufficiently large, where sufficiently large is defined by this, we have A preferring to launch a preventive war. Why is that happening? Well, when delta is large, A is patient, A cares a lot about the future, and A recognizes that in the future, it's going to have to make a large concession to B because B is going to be relatively more powerful as compared to the first stage, pre-shift. So A's incentive to fight, the temptation here, is to initiate a war under favorable circumstances and lock in a balance of power that's good for A. And if it cares a lot about the future, then paying that short-term cost right now and foregoing stealing all of the surplus by demanding x1 equal to 1 is going to look better than suffering the consequences of fighting, not fighting a war and having to provide lots of concessions to B later on. And you'll notice that because we have delta being large here and delta being large here, that this can coexist. So we can put another value here to represent 1 minus, just make sure I get this right, P prime plus CA divided by 1 minus P minus CB. And if delta is larger than both of those quantities, we have war. And that's a new rationalist explanation for war. So this is falling under a commitment problem because think about what's happening. A is fighting a war because it prefers a inefficient but advantageous war outcome, despite its costs, to a efficient but disadvantageous peace in the future. So obviously we have war costs being paid, which means we're going to have inefficiency. So there are alternative outcomes that are both going to be better for both parties. But we can't reach those outcomes because what's necessary for that to work is that in the second stage, B needs to ask for an amount that's not commensurate with its balance of power. And B can't credibly do that. Once power has shifted, B is going to say to A, hey, A, originally I told you that I would accept smaller concessions right now in this future stage, as long as you didn't fight me in the previous stage. But now that we're in this future stage, whatever has already happened has happened. Those are sunk. We can't change those values. We can't change those payoffs. We can only maximize for what's going on today. And if we're maximizing what's going on today, well, I need a sufficient amount, otherwise I'm going to fight a war, and that sufficient amount has to be commensurate with my newfound balance of power. A recognizes that this is going to happen and then chooses to fight a war instead. Okay, so what we have now discovered is we have a rationalist explanation for war. We have war in this parameter space. We have peace in this parameter space. The last question to deal with is what happens when we have a relatively small delta. So B is rejecting some X1 demands, and if we go back up, well, where was that? That's this right here. So is it possible that we have war in this situation as well, where the most A can demand is X1 equal to that quantity? Well, this is relatively easy to figure out. So what we know in this case is we are still trying to solve for what A's optimal demand is and see whether it prefers that optimal demand to preventing. And the comparison is very similar to before, except we're now inserting a specific value of X1. So we still need to compare the pre-shift acceptance payoff for A to its pre-shift war payoff. But now instead of X1 being equal to 1, the maximum that A can get away with in this pre-shift stage is X1 equal to this quantity here. So let's go ahead and substitute this value into A's payoff for a peaceful settlement and compare that to its war payoff. So its war payoff is still P prime minus CA over 1 minus delta. Let's just go ahead and double check that that's right. Yep, that's its war payoff. And we're comparing that to this quantity here. So we got to substitute X1 being equal to this value. So we have P prime minus delta P divided by 1 minus delta plus CB. That's its value for the first stage. And its value for the second stage is plus delta P plus CB over 1 minus delta. And I know, because I've done this already, that this inequality is always going to work like this. In other words, A is always going to prefer the peaceful settlement. The reason being is that, well, here we have such a contingent situation where B needs to get something because it is rather impatient. And because it's rather impatient, A is able to extract all of the value, all of the surplus in this sort of situation. And so A is going to be happy with that because it's extracting all of the surplus. All right, let's just go ahead and verify that this is true, however. So the first thing to do to make things a little bit easier might be to multiply everything by 1 minus delta to get rid of those fractions. So we get P prime minus CA less than P prime minus delta P. This is now going to be a plus CB minus delta CB plus delta P plus delta CB. We're going to see lots of things canceling here. We have a P prime and a P prime. We have a delta P and a delta P. One of them positive, one of them negative. And what else do we have? We have a negative delta CB and a positive delta CB. And so what we're left with is just CA plus CB greater than 0. So in fact, we have peace here. We go ahead and look down to this parameter space that we have as a function of delta, we get peace here. So what we see is, in conclusion, preventive war as being a rationalist explanation for conflict. If we have the states being very patient, then A is looking into the future, realizing it's going to have to make a large concession and preferring not to make that concession. It instead prefers a costly and risky war to an efficient but disadvantageous peace later. Okay, that wraps up our initial dissection on preventive war, but it still leaves an open question. Think about why war is happening here. War is happening because the shift in the balance of power is relatively large, and this is scaring A. So B is having a war fought against it because it's shifting the balance of power in a great direction, and A doesn't like that very much. That turns out to not be very good for B either, because B is fighting a war and then never actually getting the benefit of the shift in balance of power. So a natural question then to ask is, why would B ever engage in a weapons program that would shift the balance of power in that sort of system? And what we're going to be looking at in the next lecture is whether B would actually want to do that, or whether B would prefer to have some sort of other shift in the balance of power that might be a little bit more moderate. So that's going to be looking at a situation where we have endogenous armaments. Looking forward to that one. Hope you enjoyed this, and I hope to see you next time. Take care.